So when you have an experiment, that's when we're giving some sort of treatment. You're going to want to have a treatment group. So that's the group in the experiment that gets the medicine, gets the therapy, gets to listen to Beethoven while they're doing homework. Then you're also going to have a control group. This is a group where subjects don't receive the treatment being tested. So if this was a medical test, they wouldn't be getting the drug, but they'd probably be getting a placebo, which we're going to talk about. A study divided college students into two groups. One group listened to classical music before being assigned a specific task, and the other group were just given the task without listening to classical music. Researchers found that those who listened to classical music performed slightly better if they did the task within a few minutes of listening to the music, but the two groups performed equally on the tasks completed later, so the effect of listening to music was short-lived. So what's the treatment group and what's the control group? Identify the treatment and the control in the treatment groups. Okay, that was repetitive. I want to identify the treatment and control groups. So our treatment group is going to be the group who listened to classical music before being assigned a task, and the other group that didn't listen to classical music, that's going to be our control. That's our control group. A study suffers from confounding if the effects of different variables are mixed, so we cannot determine the specific effect of a variable of interest, okay? So the variables that lead to confusion are called confounding variables. Confounding variables interact with each other. Okay, so let's say I was doing a treatment, or I was doing an experiment study, and the treatment was heart medication, and it was not working, but then I found out that the person also smoked. Smoking can increase high blood pressure, I'm pretty sure. So those two variables would be confounding. It'd be hard to separate the two. That's why a lot of studies ask for non-smokers. Duly noted. Placebo, when it comes to a treatment, right? A placebo is like a sugar pill, right? It lacks the active ingredient of a treatment being tested in the study. But if you're in a medical study, you know you're going to be getting some medicine, so they have to give you a placebo. It doesn't look, it looks or feels like the treatment, so participants cannot distinguish whether or not they're getting the placebo or the real treatment. One problem with this is the placebo effect, right? This refers to the situation in which patients improve simply because they believe they're receiving a useful treatment. And this is actually pretty common. So one type of confounding, and this is the worst type of confounding, is when the experimenter somehow influences the results. And that can happen, right? We all have biases and preferences. We could be really motivated to prove what it is we want to prove, what we feel is true, but the data doesn't represent it. This can occur especially when experimenters know which participants are in the treatment and which are in the control. And the only way to avoid experimenter effect is to make sure that experimenters don't know which subjects are in which groups. And this is called a double-blind study. So a single-blind experiment, all experiments should be single-blind at least. A single-blind experiment is when the participants don't know if they're getting the treatment or the placebo, but the experimenters do. A double-blind experiment is when the participants and the experimenters don't know who belongs to the treatment group and who belongs to the control group. Typically, there's a third party overseeing it that has nothing to do with the study in order to make sure the double-blind experiment is truly double-blind. So for each of the experiments described below, let's identify the problem and explain how the problems could have been avoided. So a new drug for ADHD is supposed to make affected children more polite. Randomly selected children suffering from ADHD are divided into treatment and control groups. This experiment is single-blind, and experiments evaluate how polite the children are during one-on-one videos. So what's the problem here? Well, the problem is that it's single-blind, right? And if I have this child coming in for this one-on-one interview and I know they aren't on the medication, I could unconsciously, right, because these are possibly implicit biases, meaning we don't know about them, unconsciously not be as warm and friendly. I could be like, hi, how are you today? As opposed to if a student who came in who had taken the medication, I could be like, hi, how are you, right? A much calmer, quieter approach. And that could totally influence the experiment. So in order to fix this, it needs to be double blind study. A chiropractor performs adjustments on 25 patients with back pain. Afterwards, 18 of the patients say they feel better. He concludes that the adjustments are an effective treatment. Okay, so I have lots of opinions of chiropractors, but we'll carry on. Okay, so first off, he performs on adjustments on patients with back pain. Okay. Afterwards, so immediately afterwards, they say they feel better. So we haven't like checked the long-term effects, A. B, the chiropractor is the one asking, so he could be trying to his patients could be trying to be like, oh yeah, I feel better, and kind of people please. So we don't know if they're an effective treatment because there was also no control group. No control group. That's important, right? So see, you got to talk these things through and think them out.